Hi everyone, my name is Kaitana Wagner, and I'm going to be walking you through my honors capstone on the Engineering 100 Section 950 Lab Redesign. I was inspired to do this project because I've taught as a 950 instructional assistant for 2 semesters, and I really liked the course. There are some changes that we've wanted to make as a staff for a long time, but it is difficult to do so during the semester. Before discussing the project, a brief intro to the class. Engineering 100 is a course that is taken by all first-year engineering students and aims to teach the engineering design process, relevant communication skills, and give students a feel for what it means to work on an engineering team. Section 950 specifically covers atmospheric sensing and weather balloons. Students design their own atmospheric sensor package and launch their own designs at the end of the semester. The labs are broken down into 2 main chunks: the Skills Lab, which are taught week 1 through week 7, and teach students the underlying engineering skills needed to design their payloads, and the Build Labs, which are taught week 9 through week 11, where students construct their payloads. The Skills Labs are as follows. Week 1, students are introduced to Arduino, the microcontroller platform that the class uses. Week 2, students learn to use digital and analog temperature sensors and compare the performance of them according to their technical specifications. Week 3, students add humidity, pressure, and acceleration sensors to their payloads. Week 4, students add a battery to their payload, allowing them to use their Arduino without a connection to a computer. Week 5, students add and test a GPS unit for their payload. And week 6 and 7, students use a professional printed circuit board design software called Altium to design a PCB for their team to use. After completing these labs, students have a wide array of technical skills that are highly relevant in computer and electrical engineering fields. They also have a self-designed PCB pictured on the bottom right, which is a highly advanced piece of hardware for a first-year student to make. But as you can see annotated on the slide, labs from week 4 to week 7 contain content for more advanced EECS courses. This isn't necessarily a bad thing, but speaks to the high expectations of students in our course. The Build Labs, on the other hand, are much less formal. We have a set of tests that are required for students to complete before we allow them to launch, and give them 3 weeks to develop a physical design that will make for successful data collection. Now that we have a basic understanding of the course, we can discuss changes that were made during the redesign. This slide contains a detailed description of changes made, but also gives insight to the process used to aid our work. In general, we knew what changes we wanted to make to the course, but used the framework of element, intent, side effect, and alternative to help focus our decision-making process. Based on previous course feedback and our experience teaching the course, we identified elements that we wanted to change. We discussed the original intent of those elements and used past feedback to determine if those elements were causing unexpected side effects. And if they were, we proposed alternative methods that would hopefully resolve the unintended side effects and provide students with a better learning experience. For the sake of this presentation, we'll only be discussing major changes to the Skills and Build Labs, but additional changes were made as well, including minor quality of life improvements and other larger changes. First, the Skills Labs. The intention of these labs is to give students the skills and understanding they need to successfully design a weather balloon payload containing atmospheric sensors. In addition to this, we want to give students a fun experience that further engages them in engineering and inspires them to pursue more technical work. Although we generally believe that we accomplish this, one of the most frequent pieces of feedback we see is that the concepts taught are only relevant in EECS fields. This can make students with other interests feel left out and doesn't teach them technical skills that are applicable to their desired career paths. It also pressures students who are not decided on a major to follow a specific path, simply because that's where their experience lies. Another common complaint we see is that the pace of the lab sequence is too fast. Students cannot effectively learn the underlying concepts on a week-to-week basis and end up following labs tutorials. When we ask students questions that require them to extrapolate on their knowledge or expand on a previously taught concept, they often struggle and will need instructor assistance to be sure in their solution. Because of these side effects, we decided to shift away from trying to teach the underlying concepts and rather let students follow labs as tutorials. We can do this without much repercussion because those concepts will still be taught to students that go into EECS majors in their later coursework anyways. The time opened up by this change will allow us to add additional material that is more broadly relevant to engineering and help students go through the engineering design process in a more technically supported manner. Specifically, we added shock testing and thermal modeling to the lab work, which will engage students with their physical design earlier in the semester and give them a better tool set to analyze the behavior of a payload in the upper atmosphere. Applying the same framework to the build labs, we made the following changes. The original intent of the build labs is to ensure students' design are flight ready and to let students have a fun and memorable first year experience with their team. To do this, we left the build process fairly open and unrestricted to engage students to experiment with whatever interests them. But what we saw was the unstructured nature of these 3 weeks left students confused and unable to act on any of their more creative ideas that they had because of the lack of guidance. This meant the majority of designs were the stock design, pictured on the bottom right, of a foam cube wrapped in duct tape. While this is a perfect design from the utilitarian perspective, it is not necessarily memorable and engaging. In order to avoid this behavior, we decided it was necessary to introduce design concepts earlier in the semester to give students time to explore ideas as well as better formalize physical design requirements. In addition, we now want to explicitly encourage students to pursue creative designs by showcasing excellent designs of the past. This process led us to include formal thermal and shock requirements in the assembly and test lab description. This is complemented well by our inclusion of these design concepts in the skills lab and will tie the 2 lab chunks better together. Here you can see one of our teams who constructed their payload as a baby. Watching this group's enjoyment and engagement with their project was a big inspiration in our changes to the course, and we hope to create more positive experiences like this group had for students in the future. Although I didn't get to cover every aspect of the project, I hope this presentation was enjoyable and gave you good insight into Engineering 100 at Michigan. If you know any first-year engineering students in the future, encourage them to take Section 950. Thank you.